Let's multiply and divide some fractions, and I think the most important thing I can tell you at the very beginning of this is basically how to multiply fractions. And you have probably seen this before, but here we go. So it's kind of important when multiplying by fractions. There's a very simple thing to do. Multiply, if I can spell it correctly, multiply numerators. So we multiply across the top, basically, and multiply denominators, and it is that easy. Now, the hard part is reducing it, and when do you reduce it, and how do you reduce it? And that's still not difficult, but, you know, there can be some tricks to it. Multiply denominators. Okay, so here we go. Let's do a few examples, and I'm going to pull from some notes that I've given in the past just so I can use those same examples. I like them. They're good examples. So let's start with a pretty basic one, 2/3 times 1/5, and it's really as easy as it looks, and I will write a step that you can feel free to leave out, but 2 times 1 is the numerator, and 3 times 5 is the denominator, and that gives me 2/15, and it really is as easy as it looks. This does not reduce. 2 goes into 2. Obviously, 2 does not go into 15 an even number of times. Okay. Let's do it again. 2/3, ignore this dot on the board, times 9/10. And now things are going to get a little bit different. Okay, we have a couple options here. I can reduce now, or I can reduce later. I might make a habit of reducing now. However, the first one that I do like this, I'm going to just go ahead and reduce it later. So 2 times 9, so 18, and 3 times 10, 30. And there we go. We have 18/30. And so when I look at that, I think, well, I wonder if I can reduce it, and the answer is yes. And so I think of two numbers that multiply to give me 18, and I'm aiming for a number in the list of numbers that will go into this, and it's 6. So this is 6 times 3, and this is 6 times 5, which cancels the 6, and I'm left with 3/5, and no one is surprised. Now, I could have reduced things over here, and in the next few examples, we'll go ahead and reduce from the beginning. Let me switch markers. I don't like that one. It's dying just a little bit. Okay, here we go. Let's go to the next one. What's the next one that we did? Oh man, here's a fun one. 5/9 times 3/5. Okay, this one reduces from the beginning. If you want to, you could multiply and have 15, multiply and have 45, and that works, and it's fine, it's perfectly valid. However, sometimes it's a little more conducive to set your notes down and grab a marker and start canceling. Anything on the top cancels with anything on the bottom. Now, I say that carefully, they have to be factors, but everything here is just one big thing multiplied together, right? So 5 goes into 5 one time. So if you want to, you could say, oh, 5 goes into 5 once, 5 goes into 5 once. You can also do this. 3 goes into itself once, 3 goes into 9 3 times, and then we'll multiply whatever is left. So 1 times 1, 3 times 1, and we're done, okay? Now again, if you would have done 15/45, you'd be correct, but it does reduce, so it takes a little work. I personally like to reduce towards the beginning of the problem, and that keeps us from having to do some unnecessary work later with bigger numbers. All right, let's do 25/30, which actually already reduces. 25/30, feel free to reduce that now if you like, and we're gonna multiply it by 3/5. Okay, so again, if you're feeling like you can go ahead and reduce this one, and you can, that one already reduces. I'm not, but you could. So again, several ways of tackling this problem, but I'm gonna just start looking and seeing what in the top goes into the bottom, what in the bottom goes into the top. So does 3 go into 5? No. Does 3 go into 30? Yeah. 3 goes into itself one time. 3 goes into 30 10 times. 5 goes into itself one time. 5 goes into 25 5 times. And if you notice that we have 5/10 here, and you can reduce that, you're correct. And if you want to reduce that, you can, but not everyone notices that at this step. So let's just bring it across. 5 times 1, 10 times 1. And then if you want to go ahead and reduce now, you can, or you can put it off for about 2 seconds. Okay, let's do it. 1/2. There we go. So it's a pretty straightforward process, and again, you've probably seen it many times before. Nevertheless,
The only difficult part, or the only part that's really up to your choosing, is when to reduce and how to reduce. So let's do a couple other ones. And then we'll go to the dividing, which is super duper easy. So 75 over 80 times 10 over 3. Okay, let me point out a couple obvious things. This is an improper fraction, but we'll get over it. 10/3 is more than 1. And we also have something here that does reduce. So if you want to reduce this one now, you can. Actually, I think I am. I'm going to do that. So I'm going to pretend like I haven't even started this multiplication yet, and I'm just going to go ahead and reduce some stuff. So 10 over 3 does not reduce, but this one does. And now, again, I'm doing a problem in a different way than I did the last problem, because there are so many ways to tackle these, and when you reduce and how you reduce. But if there's something that divides into the numerator and divides into the denominator, reduce it at the beginning, at the end, whenever you want. I feel like doing it now. I know 7, looking at the 7. I know 5 goes into both of these. So I'm going to divide them both, well, by 5. So if I grab a marker out of my pocket, and I'm going to divide 5 into 80. When I divide 5 into 80, I get 16. When I divide 5 into 75, I get 15. And so this problem starts out by making us think, okay, how can I reduce that big one there? And then when I do reduce it, I have something that's a lot more manageable and probably a little easier to look at as well. So we have 15 over 16. And I'm just double checking. Yeah, I'm good. So 5 went into that, 5 went into that. I'm just dividing them by 5. It's perfectly valid. So 3 goes into that once, 3 goes into that 5 times. Let's see, what else can I do? Oh, those are both even, so 2 goes into that 5 times, 2 goes into that 8 times. And we're going to have 5 times 5. We're going to have 8 times 1, and that does not reduce. I wish it did, but it does not. So let's do one more multiplication, then we'll tackle the division. Going to erase it now. Here we go. Let's see, 12 over 16 times 1/3. Yeah, that's the problem I had. Okay, so here I am talking about my problems. That's the problem I had. That's funny in my head. Okay, so we can divide 3 into 12 if we wanted. We can also reduce this. I think I'm going to go ahead and do that, so feel free. So if you're, like, in your head, you're going, oh, well, 12 is 4 times 3, and 16 is 4 times 4, and I cancel the 4s, you're good. So we have 3/4 times 1/3, and then I'll cancel those out, and it gives me 1/4. It was really, again, that simple. So now let's divide. So the process is going to change. If you know multiplication, then it's just one extra step to get the division. So let's erase and write a few little steps. So shifting gears here, going to dividing fractions. So when dividing fractions, and then this is a process I've gained from other teachers. You do 3 things. You keep, you change, you flip. Okay, now I'm using some very unofficial math terms. They're not math terms. So I will keep this the same. I'm going to change to multiplication. And flip is not a math word. I tried it. I said it one time when I was in middle school, and my teacher corrected me, and that word has stuck with me. Technically, we are reciprocating. So we're going to keep it. Then we're going to change the sign, change the operation to multiplication, and then we're going to reciprocate. You can remember just keep, change, flip. That's fine. But these are the more technical things that we're doing. So here we go. Let's do 1 or 2 or 3 or 4 division problems, and we'll start with a pretty basic one. So we're going to have 1/3 divided by 1/2. And so we will keep it, change it, flip it. Done. Okay, so keep it. Don't change it at all. Change that to multiplication. So change to multiplication, and then reciprocate. We take the reciprocal, so it's 2 over 1, and then we'll multiply. So 1 times 2, 3 times 1, and we're done. That was so easy I almost fell asleep during that problem. Okay, so let's crank it up a notch. Let's do one that reduces, and we'll wait till the end to reduce it. So let's do 12 over 14 divided by 2 over 7. And if you're looking at this saying, hey, that reduces, you're right. Reduce it now. If you won't, I'm going to wait. Okay? So again, I'm dividing two fractions. So I'm going to keep it, change it, flip it. Keep it. So it stays the same, unless you want to reduce it. You can reduce it, and technically it is the same. You've kept it as the same equivalent fraction. And then change that to multiplication, and then we will reciprocate. Okay, let's start reducing some things here, and things will reduce quite nicely, actually. So 7 goes into itself one time. 7 goes into 14 two times. 2 goes into 12 6 times. 2 goes into itself once. 2 goes into 6 3 times. I'm trying to cover up that hole in the board. And we are left with a lot of stuff. So there was a lot of crap that just happened, and it was a big mess. So I'm going to actually start it over, and I'm not doing that to bore you to death, but I'm going to make it kind of quick, just so I can show you very quickly what that process was. So 7 into itself once, 7 into this twice, 2 into 12 6 times, 2 into 6 3 times. That's what it was, and it can really go that fast. So 3 times 1 is 3, and this is a very unnecessary step. 1 times 1, I know you don't see the ones, but when things go into itself, it goes one time. 3 over 1 is 3. Wow, that was easy. Okay, let's do a couple more, and these last two are going to be written very differently. So we see division of fractions usually as fraction, division sign, fraction. But now we're going to see it as a fraction within a fraction. It's called a complex fraction, actually. 1/4 divided by 1/8. Whoa, things just got crazy. But the way I just said it indicates how we should write it. So let's just keep going, and it'll start looking like what we just did. So 1/4 divided by 1/8. Okay, that was easy. Well, keep it, change it, flip it. So keep it, change it, flip it, bop it, pull it, twist it. Okay, anyway. And we can multiply across the top, multiply across the bottom. You can reduce now if you want. I'm actually not. I'm going to just go ahead and 1 times 8 and 4 times 1. And 8 divided by 4 is 2, and we're done with it. So this one actually cleans up very nicely. Let's think about this one for a second. This one kind of makes a little sense if we think about it. So I have 1/4 of something. If I have a piece of pizza, it's divided into 8ths, and I have 1/4 of it. I have these two slices right here, right? And I'm going to divide it by 1/8. Okay? So if I divide this thing by 1/8, it sounds kind of ridiculous, but multiplying instead by 8 means that I'm taking 1/4 of this pizza with 8 slices, and I have 2 slices. Okay, that was a very muddled explanation. So let's do another one without pizza. Oh, but I'm hungry. All right, 12 over 13 divided by 4 over 39. Here we go. 12 over 13 divided by 4 over 39. And we're going to do 12 over 13 times 39 over 4. Let's start reducing some things. So, let's see. 13 goes into itself one time. 13 goes into 39 3 times. Not obvious, but it works. 4 goes into itself once. 4 goes into 12 3 times. All right, here we go. 3 times 3, 1 times 1, 9 over 1. There we go. We're done.